So let's talk about friction real quickly. I have the block, I have the mass on it just to make the normal force a little bit greater so we have some measurable friction. And then I have the Newton meter or the force scale here. So this is going to determine the applied force. So if I pull with this scale and I pull all the way up to 1 Newton, but the object's not moving yet, then what must the force of friction be? Well, even though we have a formula that says the force of friction is equal to mu times the normal force, in this case, I'm pulling with 1 Newton, the object's not moving, and so the friction force has to be also 1 Newton. Friction force can never be greater than the applied force. It's always going to be it's always going to be equal to or less than the applied force. So in that case where it wasn't moving, I applied 1 Newton, didn't move, friction was 1 Newton. So now I can keep pulling until it starts moving. And actually it looked like it was about 2.5 when it first started moving. When I did the math, I wrote down 2, but the weight of this object is approximately 10 newtons. I'm trying to make the math simple here, and so this would be static friction. So when it just started moving, originally I thought it was 2. So if it was 2 newtons divided by the normal force, which is 10, I get 0.2. Now if it actually was 2.5 newtons instead, then I'd have 2.5 newtons over about 10 newtons, and so I'd have about 0.25, no units. That would be my coefficient of static friction. That's where it spiked and when it started moving. And so what I want to do next is I want to pull this at constant speed. So if I pull this at constant speed, it's going to be kinetic friction. And when I pull it at constant speed, looks like I'm getting a number. It's bouncing around a little bit. Maybe if I averaged it out, it might be about 1.8, well, 1.9 there, and then between 1.7 and 1.8. When I pull it at constant speed, it's in equilibrium. F net has to be 0. And so again, gravity and the normal force are equal to each other. And because it's going at constant speed, the applied force has to be equal to the friction force. So when I did this before, I said that the applied force is about 1.8 newtons. So therefore, the coefficient of kinetic friction is the friction force divided by the normal force. 1.8 newtons divided by 10 newtons gives me a coefficient of kinetic friction of 0.8. And for just about all objects, the coefficient of static friction is going to be greater, and the coefficient of kinetic friction is going to be less. In other words, it takes a greater force to start the motion and a slightly lesser force to continue that motion at a constant speed.